Hello, trigonometry students. This is part 2 of the video lessons for lesson 16, solving trigonometric equations. We're still working through complex versions of trig equations. And so in our last video, we saw factoring, we saw Pythagorean identities and substitution, and we even saw answers not on the unit circle. As you can see in the screen, we're going to talk about that again in more detail to give you another example. For this first one, this is a compound trigonometric function because as you can see, inside my parentheses, I have an additional function 2t. That's not going to affect how I start solving the equation. I'm still going to add rad 3 to both sides. And I'm still going to divide both sides by 2. From here, I really want to weigh heavily on my inverse trig. So I know with inverse trigonometry, I can rewrite this with the input 2t being equal to inverse sine of the output rad 3 over 2. Inverse side of rad 3 over 2 has one solution in quadrant 1 because it is an inverse function. But we want to answer this for all possible values, so we want to think of our unit circle, and we don't just want to look in quadrant 1. My first equation is going to be 2t equals, and let's go ahead and do this one in degrees, so I'm going to say 60 degrees. And then the same thing happens in quadrant 2. 2t is equal to 120 degrees. What makes this compound is that I'm not done. I still have to solve for t. What you want to make sure is if you're solving for all real numbers, you put your plus or minus 360 before you divide by 2, because that part is also affected by changing the period, which is basically what the 2t is doing. So now, divide everything by 2, and we get 30 plus or minus 180n and 60 plus or minus 180n. So that's how we solve a compound trig function. It just has one additional step with one word of caution, making sure you include the plus or minus 360n before you divide by 2. You actually want to do that even if you're not solving for all real numbers, because you may find additional solutions from 0 to 360 that you wouldn't have caught beforehand. For example, 30 plus 180 is 210, which is on the unit circle, and 60 plus 180 is 240, which is on the unit circle. Now let's look again at an example where the answers are not on the unit circle. Rely heavily on your inverse trig here because this is also a compound function. Use your calculator set in degree mode to find the inverse tangent of 1/4. I'm getting that this is about 14 degrees, which is actually pretty small and located in quadrant 1. So my first solution is x over 2 equals 14 degrees plus or minus. Please don't put 360. The period of tangent is actually 180 degrees. And then if you think about it, you don't actually have to find the solution in the other quadrant because the 180 actually gives you the solution in the other quadrant. We would just take 14 degrees and add a 180, which is what's expressed here. So this is actually all of our solutions. We just need to finish solving for x. Multiply both sides by 2, and you get 28 degrees plus or minus 360n. All right, let's take a look at our last example. We can use techniques for solving trig equations and not actually solve the equation. That's going to be finding an inverse trig function. So here we have f of x equals 2 cosecant 3x minus pi halves minus 4. This is as complicated as I can make it. If you remember from previous classes, you want to switch your x and y. and then you want to solve for y. So also need to remember that f of x is just function notation for y. So step 1, x equals 2 cosecant 3x minus pi halves minus 4. From here, your order of operations really matter because we've got a reciprocal function, but that reciprocal function is not alone. Eventually, we're going to need to reciprocate the cosecant. But before we can do that, it's got to be by itself. Start by adding 4. Be careful when you move on to your next step. We do want to divide by 2, but it's a really common mistake for students to divide the 4 by 2 and not include the x over 2. So it's probably safer if you leave it as this entire rational expression. And now that your cosecant is isolated, we can reciprocate. Reciprocating a fraction means to flip it. So I'm going to flip 2 over x plus 4. Reciprocating cosecant turns it into sine. Oh, I forgot to actually put y. Hold on, I want to fix that one. Back at the very first step, switch x and y. I've still been writing x the entire time. 3y, 3y, 3y. All right, now that it's sine, we can use an inverse sine function. I'm going to put it over here on the left-hand side. The input becomes the output, 3y minus pi halves equals inverse sine. And what was previously the output, this expression right here, is now going to become my input. And I can wrap this equation up in 2 more steps to get y by itself. So the next thing I'm going to do is add pi halves to inverse sine of 2 over x plus 4 plus pi halves. And then be careful when you divide by 3, because this is kind of messy, and your answer is pretty messy. In fact, the safest way to divide by 3 is probably to write 1/3 inverse sine for the first term. And then when you divide this one by 3, it becomes pi 6. And that is your inverse function. Although if you were writing it in proper notation, you would write it one more time with the inverse. This actually concludes the video notes for lesson 16, solving trig equations with more complex equations. Thank you for watching.